and welcome to Intro to Gathering Data. Our essential question is, how can bad sampling affect my results? We're going to answer that kind of toward the end of the notes. But first, we have to look at how our data is actually gathered, because guess what? Your big goal in statistics is to make inferences about your population. You want to know what is the big picture. The problem is you don't want to go around to every single person to figure out what the big picture is, and we're going to talk about some reasons why. So here's the thing. When you are given data, you have a couple things. You can display the data, you can describe it, and summarize the data. The big problem is if you got some really crappy data, then you're going to have some crappy results, and they're going to be false, you're going to get sued, or potentially even fired. So the big question we have to ask is, how can we make sure that that data represents the population? How can I be confident that my data is okay to use and okay to make inferences and predictions and whatnot? So I've got three big ideas that I think are going to help you. So the idea of the first one is that you're going to examine a part of the whole. And I have a spoon there to help you think about cooking in a kitchen. Let's say you've got some friends over and you want to make a big old pot of soup because, let's face it, it's cold that one day in Texas. So you're stirring, fun. I'm willing to think before you serve it, you're going to want to taste it or take a sample. Yep, you can see where I'm going. Again, you don't want to eat the entire pot of soup because then, well, my friend, you have none to serve and you got to start yourself all over. But you're at least going to dip your spoon in it, taste it. I think it needs this, or I think it's perfect. That's the biggest idea that you're going to want to do. Because let's face it, if you want to know something about the population, examining everybody is impossible. And more importantly, it's just impractical. It's stupid. It's a waste of time. It's exhausting, and ain't nobody got time for that. So the biggest thing is some people do opinion polls, kind of like surveys. The biggest thing that they have to ask themselves is, well, the people that I got, was it representative of everybody's opinion? Can I take this further? Because again, they're designed to gather info about the population. The second big idea is randomization. Again, go back to that pot of soup. Let's say you've let it sit for a while. You're coming back just to see if it's still tasting good. Let's say you put that spoon and you just dip it in the top of the soup. I'm willing to bet if you're making something with chunky vegetables, you probably didn't get a taste of what the actual soup tasted like because all those veggies are at the bottom of the pot. Let's say you serve it. Oh no, the potatoes are bad. Because you forgot to stir the pot. Stirring the pot is kind of what I call randomization. You stir it, then you try it, and then it really does taste like the population. Because let's face it, randomization, when it comes down to it, protects you against factors that you know are in your data. So you try to randomize those facts to create, hopefully, something good. Or it even protects you from influences or features in your population that you may not even know about. Because let's face it, everything can affect your data, even ways that you can't even imagine. It's utterly crazy. So the biggest thing, randomize to make sure that your sample overall looks like the population. Stir the pot so that that big old spoonful tastes enough and looks like the population. Our last big idea is to consider how large of a spoon or how large of a sample do we need for that to be reasonable and actually represent that population. Biggest idea, it's the sample size that matters. And this sounds intuitive, yet also kind of interesting, because it's really not the size of the population that makes a difference. It doesn't matter if you have a 1-gallon pot or a 2-gallon pot or a 3-gallon pot of soup, because guess what? If you've stirred it, you have a bigger spoon, you have a bigger sample. It's still going to taste fine. You're still going to be able to taste that soup, because guess what? The fraction of the population that you sample doesn't matter. It's the sample size. It's the size of the spoon itself that matters. So here's the thing. Why not talk to everybody in the population? Why worry at all about the sample size or finding the Goldilocks right amount? Just go door to door, bother people, because together we count. Here's the problem with that. Because you can probably come up with some on your own. Let's say they're not home. What happens if they're traveling the country? What happens if they've moved? The population is constantly changing, and the census just isn't going to get it right. It's a good idea, but it's not 100% as accurate as people think it is. So, why is a class called statistics? What's the point of it? What does that even mean? Well, guess what? Models are used all the time in mathematics to represent a reality. Go figure. So using parameters is the key to those models. The parameters are what you're trying to estimate about the population, like maybe the average per age of a person who gets a cell phone for the very first time. Numbers like that are what matter. What's the average height of a typical 16-year-old? Those are population parameters. And the way that you get those is by grabbing your sample. And a summary that is found from that data is a statistic. And a sample statistic is what's used to estimate the big population parameter. I found 30 16-year-olds. I did their ages, and I found out their average age. I just found a sample statistic because I'm going to use that to estimate what the actual average is. And that launches us into some bigger discussions for statistics. So here's the problem. We're going to close with a couple cautions. Take a look at ABC, pause the video, and see if you think what is wrong with those sampling methods. Welcome back. Hopefully you paused the video. On A, you should have noticed that people slammed the door or refused to cooperate, or you literally got no response, hence non-response bias. The next one, you talked to people from Weight Watchers. None of them have had chocolate in 5 years, but sure, I'm going to try yours. This is the opposite problem. This is a response bias because the behavior of that recipient leads to some kind of favoring. Or maybe they've lied, or they've given this expected answer. Talking to your 16-year-old daughter saying, hey, have you smoked at all? No, absolutely. No, oh no, not me. You're probably going to get a response bias. Only pulling people from a specific area like Richardson, Texas, that's an undercoverage problem. Because guess what? Just because that's how Richardson people feel doesn't mean that's how all of Dallas feels, or Austin, San Antonio, Oklahoma City, Little Rock, Los Angeles. You can see the problem with that. All right, take a look at D and E. E is my personal favorite. D, you put the bars along with a questionnaire next to a time clock. Here's the thing. If I don't like chocolate, I'm probably not going to stop or even care that there's chocolate there in the first place. So, voluntary response bias. Individuals with strong opinions will choose to comment. The last one, again, is my personal favorite because you're asking people to taste the manifestation, the majestic consistency, and the astounding eminence that is this piece of chocolate. Guess what? You just made a poor wording bias. It occurs when a question is confusing or leading, so pushing people to have a specific answer. Well, knowing that this budget is going to affect our military, which is going to defend our country, how do you feel about it? Very poor wording. And again, if you are in fact taking the AP statistics test, be sure you comment on which way it is biased. For example, on E, because all those words are positive and talking about the excellence, I'm persuading people to say they love my chocolate, which means I am overestimating the amount of people. That's how you describe the way. So, example 2, identifying bias and the direction. Taking a look at a parent for a football player concerned about budget cuts, which can affect athletic funding. Went to a game, a football game. Well, she's made a classic case of response bias because she's going to favor the no's. They don't want to cut the budget if it affects athletics because guess what? You're at a football game, dum-dum. All right, B, I love to vote on The Voice for my favorite contestant, American Idol. I kept voting for my favorite at least 5 times. Good job, dum-dum. You messed up the data because that's voluntary response bias. You love them. You're overestimating the people that actually like a contestant. This one's a little bit longer. Taking a look at ABC Nightline. Obviously calling in to see how they agree on something. Here's the problem. If it's something people really care about, they're going to call in, which is another classic case of voluntary response bias, which can tend to overestimate the number of people who care about a particular topic. Thank you for joining and continue to watch more statistics videos.